guys, we left off on number 12 when you guys were coming back in. So number 12, divide by power of 10. Divide by power of 10. Now, if you remember when we used to multiply by a power of 10, we found out through models and working standard algorithm and comparing the models and standard algorithm that if I'm multiplying by a power of 10, I can move the decimal every how many powers of 10 I have to the right, which makes sense if I had, let's see, 300, if I had 300 of something. Let's say I have 3/10 of something, and I divide that up by 10 more. Okay, it makes sense that if I had something less than a whole and I divide it up even more times, another multiple of 10, then that number would become even smaller. So instead of moving the decimal to the right, then we figured out that we could move the decimal to the left if we're dividing every how many multiples of 10 it is, and it gives us a smaller number. And again, that makes sense. If I had 3/10, that's already small, and if I divided it up 10 more, then I would have even less, so 300. Okay, so let's use that same theory on this one. All right, if I have 594 and 2/10 of something, and I'm dividing it by 100, well, it makes sense that if I have about 600 of something and I divide it by 100, then I should have about 6. So let's use our theory that we think on moving decimals based on the number of powers of 10. So 594 and 2/10 divided by 100. And through modeling and standard algorithm, we figured out that if you move the decimal place to the left, if you're dividing, the same number of times that you have your multiple of 10, it will put the decimal in the right place. So 5 and 942 thousandths. And that makes sense. Again, if I had about 600 of something and I divided it by 100, then I'd have about 6 of it. So I had 5 and a little bit more, 500 and a little bit more, so I ended up with around 5 of it. So that makes sense. Okay, shade in the model to represent 83 hundredths. Tenths, hundredths, 83 hundredths. Well, we know that this is a 100 square. And we know that each column is 10. So we would have 1, 2, 3, 4, 5, 6, 7, 8. This would give us 80 hundredths. Our number says 83 hundredths. So we would have 1, 2, 3 more filled in. So we have our 80 here in the bed, we have our 80 shaded here, and then 1, 2, 3 more. So 83 hundredths, because the whole thing is 100, are shaded. Okay, now, be very careful on test. You guys see multiple choice and you think, oh, just circle one. No, it says circle all correct statements, all correct statements. So if we look at this one, we have 100 tenths hundredths is equal to 1,000. Well, that's not true, is it? No, 100ths is a bigger value than 1,000, isn't it? Would you want, if I had a something in, you want 100th of it, or would you want 1,000th of it? 1,000th wouldn't be very much at all, would it? So no, that is not true. 642 and 3/10 is greater than 642. Well, the whole number part is the same, so we keep going. This one doesn't have anything else. This one has 3/10 more, so yeah, that is a correct statement. 682 thousandths, because we have tenths, hundredths, thousandths, is less than 73 hundredths. And remember, it doesn't matter how many digits there are. You go by place values. So you always start by looking at the whole number. Well, neither one of them have a whole number, it's just 0. So then you move to the tenths. You have a 6 and a 7. Who's smaller? The 6 is. So yeah, this is a true statement. Even though it has more digits, it is less than this that only has 2 digits because it has 6 tenths and this one has 7 tenths. Okay, so that's a correct statement. 4 and 76 hundredths is less than 3 and 982 thousandths. Again, it's not based on what how many digits it is. This one has 3 digits and this one has 4 digits, but look at the whole numbers. This is 4 whole ones and this is only 3 whole ones. So is that a correct statement? This is less than that? No, that's not a correct statement, is it? Okay, and then the last one, 31 and 0 hundredths equals 31. Well, I don't have anything in my decimals, so if I cover that up and I just have 31 point, then yeah, that's the same as just 31, isn't it? So that is also a correct statement. So be careful on test. Make sure you look at each one. It's not a multiple choice, just a basic multiple choice. You can't just pick one answer. Circle all correct statements. Okay, and then the last one. It is also circle all the correct ways to represent the number 4 and 824 thousandths, tenths, hundredths, thousandths. Well, if we look at this first one, if I multiplied 4 times 1, would I get 4 whole ones? Yeah, and that's what it says I have right there. And I have 8 times 1/10. 8 times 1/10, that's 8 tenths. So, yeah, I have an 8 in the 10th spot. And I have 2 hundredths. So 2 hundredths. That would be 0.02, so I would have 2 in the hundredths place. Yeah, and I do. I have 2 in the hundredths place. And I have 4 times 1,000th. Okay, so, well, yeah, that would make sense. I would have 4 thousandths, and that is in the thousandths place. All right, and so that is a correct statement. All right, now, reading it in words, 4 and 824 thousandths. Thousandths means it has 3 digits after the decimal, and yeah, we have 3 digits past the decimal, so we have 4 and 824 thousandths. So yeah, this statement is also correct. The next one, 4 and 824 hundredths. Well, we just said it had 3 decimal place values, and this is hundredths. That's only 2, so that's not a correct statement. And then the last one, I have 4 whole ones. Yeah, I do. And I have 8 tenths. Yes, 8 is in the tenths place. And I have 2 hundredths. And yes, 2 is in the hundredths place. And 4 thousandths. And yes, 4 is in the thousandths place. So this one is also correct. So on the test, be very careful if you see multiple choice. It's not a just pick one and move on. You're going to have to look at all the choices and circle all that are correct. Thanks, guys. Bye.